All right, let's talk about one of the biggest, most mind-bending goals in all of tech, building a true artificial general intelligence, or AGI. And we're not just talking about smarter chatbots here. We're talking about a machine that can genuinely think, that can reason and learn pretty much anything, just like you or me. But here's the thing. That whole quest, it's built on a question that we're still wrestling with. What even is intelligence?
And that question, it's right at the heart of what we're digging into today. You've got this incredible race to build an artificial mind, right? But it's created this huge split. On one side, you've got the engineers with a super practical, let's get it done approach. And on the other side, you've got the philosophers who are kind of raising their hands and saying, hold on a second, are we even asking the right questions? It's a fascinating clash. Let's get into it.
So, to really get this debate, we've got to start with the basics. What's the standard answer? What's the go-to definition for general intelligence that pretty much everyone in AI is working with? This is the bedrock.
Okay, so here it is, from researchers Legg and Hutter. Basically, intelligence is all about how good an agent is at getting things done. And an agent can be anything. You, me, a squirrel, a robot, whatever. If it can achieve its goals and do that in all sorts of different environments, then boom, it's intelligent. It's simple, it's practical, and it's all about achieving goals. This is ground zero for our first point of view.
All right, so let's put on our engineer hats. This view is really championed by AGI researcher Ben Goertzel, and he's got this idea he calls Patternism. What it does is take that simple, goal-oriented definition we just talked about and turns it into an actual blueprint for building an AGI. It's the how-to guide.
The core idea here is surprisingly simple. Intelligence is basically just really, really good pattern recognition. That's it. A mind isn't some magical, mysterious thing. It's just a system that's amazing at finding patterns, patterns in the world, and even patterns in itself, and then using those patterns to get stuff done. Like spotting a pattern in the clouds to know it's going to rain, or seeing a pattern in traffic to dodge a jam. It's all about the patterns.
So how does this pattern-finding machine actually work? Well, Goertzel says it's driven by a few key things. You've got evolution, which is just a fancy way of saying the system keeps the good patterns and ditches the bad ones. Then there's association, where it links related ideas together. Smoke is linked to fire. These patterns get organized into networks. Some are hierarchical, like a classic pyramid structure, top-down. Others are heterarchical. Think more like a messy spiderweb of connections, way more flexible. And eventually, the system even starts recognizing a pattern of itself. It develops a self-structure.
And you can boil all that theory down into a really practical, step-by-step loop. It's beautiful, really. Step 1, the AI looks at the world. Step 2, it asks, okay, what can I do right now to get closer to my goal? Step 3, it does the thing. And step 4, it checks the results. Did that work? Awesome, I'll remember that. Did it fail? Okay, note to self, don't do that again. It's a constant cycle of observing, acting, and learning. It feels so logical, right? A perfect, clean engineering solution. But what if the whole thing is built on an assumption that's just wrong?
And this is where things get really interesting. Right when the engineer's path seems so clear and straightforward, a whole different perspective comes in and basically pulls the rug out from under it. It's the philosopher's turn, and they're here to question the most basic assumptions we just made.
Yeah, this is the big one. Posed by thinkers like David Weinbaum and Viktoras Vaitas, they ask a simple but totally devastating question. Where does the agent even come from, and who gives it its goals? Think about it. That whole engineering model we just saw, it just assumes there's an agent. It assumes it's separate from its environment. It assumes it has goals. But why? In the real world, are we just born with a list of goals, or is something else going on?
This really lays out the two sides of the argument perfectly. On one hand, you have the standard AGI assumptions. You start with an agent, you give it some problems, and its job is to solve them. Simple. But the critique says, no. The boundaries that create an agent aren't just given, they have to be formed. Goals don't come prepackaged. They emerge. So maybe real intelligence isn't about being good at solving problems. Maybe it's the ability to identify what the problems are to begin with.
This whole critique opens the door to a completely different idea, which they call open-ended intelligence. And the key shift in thinking is right there. It's not about the state of being smart. It's all about the continuous process of becoming smart. It's a much deeper, more fundamental idea. This quote from Weinbaum and Vaitas just nails it. General intelligence never starts with solving a problem, but much earlier, in the formation or identification of the problems to be solved. Let me put it another way. The engineer is trying to build a perfect machine to win at chess. But the philosopher is asking, yeah, but what's the process that came up with the idea of chess in the first place? It's that creative, messy, problem-finding part that might be the real secret sauce of intelligence.
So you might be asking, how does this actually work? Well, the first big idea is something called individuation. The best way to think about it is to just forget the idea of a ready-made agent. Instead, picture a chaotic soup of stuff, all interacting. Individuation is the magic moment when a stable thing, an individual, sort of crystallizes out of that chaos. It draws a boundary around itself. It's how a single cell forms a membrane and becomes separate from the water around it. It's the birth of me versus not me.
And once that boundary exists, you get the next key idea, sense-making. Because now, things happening across that boundary actually mean something. Sense-making is the act of creating a world. It's saying, this is food, that is a threat. This is safe, that is dangerous. It's not about passively taking in data from a world that's already there. It's about actively creating a world that makes sense to you.
So, if an agent isn't a fixed little robot, what is it? In this view, it's called an assemblage. Think of it less like a solid object and more like a whirlpool or a city. A city is definitely a thing. It has a name, a boundary, but it's also a constantly changing collection of people, buildings, and traffic. It's never the same from one second to the next. An intelligent agent, in this view, is just like that. A stable pattern, but one that's always in flux.
Okay, so let's pause. We have these two huge ideas that seem to be in total opposition, right? You've got the engineer, laser-focused on building a problem-solving machine, and you've got the philosopher, talking about this deep, self-creating process. So, which one is it? Are they mutually exclusive? Or, just maybe, are they both right?
This table really brings it all together. The patternist view, its focus is on being intelligent. The core process is problem-solving. The open-ended view, its focus is on becoming intelligent, and its core process is problem formation. And the metaphors, man, they are just perfect. Is our goal a master chess player, or is it the messy, creative, evolutionary process that invented the game of chess itself? That's the difference.
And the answer, it seems pretty clear, is 2. We need both perspectives. You absolutely need Goertzel's pragmatic engine to actually do things, to solve problems efficiently. But you also need Weinbaum and Vitus's open-ended creative force to figure out which problems are worth solving in the first place. It's like one view gives you the engine of a car. The other view explains the evolutionary forces that created the fuel, the driver, and the entire concept of a road.
So that leaves us with this one huge final question. As we build these incredible systems, what are we really aiming for? Are we trying to design the perfect problem solver for the world as we know it now? Or are we trying to light a spark, to create a universe that's so creative it can invent and solve problems that we, its creators, can't even begin to imagine? That right there is the choice at the very heart of this whole quest. Something to think about. Thanks for tuning in.